Alright, so we're going to do area of a sector practice. Now, I mentioned in the previous video where I was going to show you how the ratios of the area of a sector and the area of a circle is equal to the ratio of the arc length to the circumference. So, I said using the mathematical operations to get A by itself, here we have two ratios equal to each other. Now, if I didn't want to work with fractions, what I'm going to do here is just cross multiply them. So I'm just going to multiply 2 pi r, again 2 pi r to the a, and then multiply pi r squared to this r theta. So again, I'm just doing cross multiplication. So what's left is, when you do cross multiply, you don't have a fraction anymore. It's just simply a times 2 pi r equal r theta times pi r squared. Now, when you're multiplying, and I want to get basically a by itself, I'm going to divide 2 pi r because I want to get a by itself. So I divide on the left, I got to divide on the right. So 2 pi r. So when I'm dividing, this is what's it going to look like for now. A equals, and what I'm going to do is I'm going to keep the factors separate. So r theta pi and r squared. Now I'm not going to multiply the r's, I'm just going to keep it separate for now. Divide by 2 pi r. So what's going to happen is we're just going to cross out, divide the common factors. Since there's an r on the numerator and we can divide with the r on the denominator, those two will divide. Since we have a pi in the numerator and a pi on the denominator, those two are going to divide into 1. So what we are left with is basically a equal theta r squared over 2, which is equivalent to the formula in the book, 1/2 r squared theta. But you can rewrite it as r squared theta divided by 2, because whatever you have here basically is like a whole number number times a fraction, just multiply to the numerator, which is basically r squared theta over 2. So that's how we got the formula. So what I'm going to do is I'm going to write this formula up here. This right here was the process how to go from the two ratios to the formula for the definition of area of a sector. So again, the definition of area of a sector was simply from the book, A equals 1/2 r squared theta, but you can also rewrite it as r squared theta over 2. So that's all you have to do. Now, say that the radius is given, which is 12, and our center angle is given as basically, let's say 3 pi over 5. Alright, so say we are looking for the area. Now, if you have radians as a fraction, then I would highly recommend to use this. So A equals 1/2, times r squared. So basically r is 12. That means it's going to be 12 squared times our theta, which is 3 pi over 5. So what we're going to do is PEMDAS. Nothing inside the parentheses. Nope. We're done with parentheses. Next is exponent. So we have 12 squared. So we're going to have 1/2. 12 squared is basically 144. And then 3 pi over 5. Alright. So you can multiply the 144 to the 1/2, or you can multiply the 144 to the 3 pi over 5. But to make it easy, let's do 1/2 of 144. So I'm just going to do this step by step. So first I multiply the 144 to the 1/2, which is basically 144 over 2 times 3 pi over 5. To make your job easier, I would just simply do 144 divided by 2, because 144 is an even number and can be divided by 2. So 144 divided by 2 is basically 72 times 3 pi over 5. And now we have a whole number multiplying to a fraction, so the whole number times the numerator. So 72 times 3 pi, that's going to be 216 pi over 5. So this is our area of a sector. And then let's check. Is there anything common between 216 and 5? 216, since it ends with a 6, that usually divisible by a 2 or a 3 or a 6, not a 5. So nope, there's nothing common between 216 and 5. So area of sector is basically 216 pi over 5. And that is our final answer. Alright, in this example we have a picture given with the radius label, and it's asking for the area of the sector with our center angle 3 pi over 4. So let's write out our information that we know. Radius is 5. Our center angle is 3 pi over 4. And of course, when you do an area of sector, make sure that our theta, or angle theta, or center angle is in radians, which it is. That's fine. If it was in degrees, then we just convert it to degrees. So now we're just going to do area of a sector. So I'm going to do it right here. A equals, since our center angle is in radians, which is a fraction, I'm just going to use this one first. So 1/2 times, our radius is 5, so 5 squared, times our center angle, which is 3 pi over 4. Alright, so PEMDAS. Anything inside that we can work on the parentheses, adding, subtracting, multiplying? Nope. Next is exponents. So 5 squared, so the 25. So I'm bringing down to 1/2. 5 squared is 25. And then the 3 pi over 4. So, okay, we're done with the exponents. Next is multiply or divide from left to right. So I'm going to multiply starting from my left. So 1/2 times 25. So again, 25 is a whole number times a fraction, the 1/2. So it's going to be 25 over 2. And I can't simplify that without becoming decimal, so I'm just going to leave it like that. And then bring down the 3 pi over 4. It's still multiplying, so I'm going to continue multiplying. Since it's a fraction times a fraction, numerator times numerator, denominator times denominator. So 25 times 3 pi, that's going to be 75 pi over 2 times 4, which is 8. Alright, let's take a look. Is there anything in common between 75 and 8? 75 ends with 5, so it's usually divisible by 25 or 5. 8 is divisible by either 2 or 4, so nothing in common. So our area of a sector, A, equals 75 pi over 8, and that's our final answer. So, just like arc length, area of a sector, your central angle has to be in radians. If you were given in degrees, then just follow the conversion rule, convert to radians. That's all you gotta do.